This is Module 1, Topic 1, Lesson 3, Activity 3.2. Go ahead and take a moment and read the activity description. Pause here. In this activity, you will calculate the area of composite figures composed of triangles, rectangles, trapezoids, and circles. I am now going to model how you should think through and work through question number 1. Also for this activity, it might be helpful to have colored pencils on hand as it may help you master this skill today. Let's get started. Question number 1. A figure is composed of a rectangle and 2 semicircles. Determine the area of the figure. So the question says I'm looking for the area of a figure. I've got a rectangle, which I'm going to highlight in blue. And I've got 2 semicircles, which I'm going to highlight in pink. Also, think about this. If I have 2 semicircles, what could I do to make solving a lot easier? Pause here. If you said something like put them together to create one full circle, you are absolutely correct. Also, there's a little note right here that kind of helps you remember a semicircle is half of a full circle. So I can take these 2 semicircles to create one full circle, and we know the area is equal to pi r squared. And with our rectangle, which I'm doing in blue, we know that the area is equal to base times the height. Hopefully, if you did it correctly, you should have identified your base in the rectangle as 13 and the height as 6.5 centimeters. For your circle, you would need the radius of one of those circles, or of the circle. So the radius is not that 6.5, but think, how would you get the radius, and what does that 6.5 represent? Pause here. To answer that question, what you should have said was that 6.5 represents the diameter of the circle, and to get the radius, we would need to split that in half or divide it by 2. And my work is shown here. For the area of the rectangle, you got 84.5 centimeters squared. And for the area of the circle, you should have gotten 33.17 centimeters squared. And do not forget those units. But that is not our final answer, because there's one last thing that you need to do to find the total area of this composite figure. Think about what that is. Pause here. Hopefully you said, add it all up. You're absolutely correct. Add it all up and you should get 117 and 67 hundredths centimeters squared is the answer that you should have gotten for question number 1. Now move on to question number 2. Now that you know how to solve for the area of composite figures, you're going to go on to questions number 2 and 3. Remember, use colored pencils or whatever you have to identify each of the shapes in the composite figure, and then think, how would I find the area for each of these figures? Question number 2 reads, a figure is composed of a trapezoid and a semicircle. Determine the area of the figure. And question 3 reads, a figure is composed of a triangle and 3 semicircles. Determine the area of the figure. Pause here to solve. For the area of a trapezoid, you should have found that the formula is area is equal to 1/2 times base 1 plus base 2 times its height. And remember, its height is not slanted, but it'll always be perpendicular to its base. And the area for a circle, you know, is pi r squared, but for a semicircle, you would need to either multiply it by 1/2 or divide it by 2. I simply wrote it as pi r squared divided by 2. And now you will see my work. Here is my work. In purple, the area of the trapezoid is calculated, giving us 77 feet squared, and in orange, the area of a circle is calculated, giving us 14 and 13 hundredths feet squared. But there's one last and final step, and that is to, yes, add it all up, find the total composite area. And that you should get 91 and 13 hundredths feet squared for question number 2. Now moving on to question number 3. A figure is composed of a triangle and 3 semicircles. Determine the area. Now with this, it's a bit tricky. Think, what could we do with 3 semicircles? There are several ways to solve. Pause here if you have not already solved. If you have, my work is about to be shown. Here my work is shown for the area of the triangle. You should have gotten 173 inches squared. And for the area of the semicircles, you should have gotten 471 inches squared. Notice how I got all the way up to 50 pi and then realized I have 3 semicircles, so at some point I'm going to need to multiply this by 3. So then when doing that, you should have gotten 471 inches squared. But that's not our final answer. If you haven't gotten this, copy it down. But our final answer is about to be shown. Now, the total is 644 inches squared for problem number 3. And that concludes this activity. In summary, decomposing shapes into smaller, familiar regions is a strategy used to determine the area of a composite figure.